Hello, welcome to another demo showing you how to develop stream processors that are communicating with each other using CloudEvent as the abstraction mechanism. For that, our team has developed a few archetypes that can be used for quickly getting started and generating a Maven project that consists of correct usage of the API dependencies, Docker Maven plugin for building a Linux container, as well as generating a custom resource file for later deployment or registration of the stream processor. The prerequisite for this is that we have strimc deployed in order to be able to run Apache Kafka, because that's the technology used behind the scenes in our event flow that's communicating with each other using CloudEvent. We also have the CloudEvent flow component that will be later used for actually composing a stream processor pipeline based on artifacts that we developed. So I have prepared a project which uses strimc, meaning Kafka on OpenShift, as well as the event flow component with the manager UI and an operator in the background. Maven Archetype are ready for quickly getting started, and one of the things that I would like to demonstrate here is creating a simple stream processor that represents a sink, which means that the component is receiving cloud events that are part of the event flow in this demo. So let's quickly go ahead and create a project leveraging our sink archetype here. There is a few arguments that you need to provide here: the group ID, the artifact ID, and of course you need some Docker Hub ID in order to build a full qualified name for a Linux container image. Okay, I'm generating a project. The Maven interactive mode here from the archetype is then asking me for confirmation if all the provided arguments are correct, and yes, indeed they are correct. And now I can go to the project called my sink. The project itself is a complete valid Maven project which has all the dependencies correctly set up, and it consists of two source files. One is a Java file that's representing our sink component, which uses our API. Let's take a quick look there. We have a few imports here. One is the CloudEvent namespace with the actual cloud event, and then the others are from the Dataflow runtime environment SDK. So we use the component for CloudEvent component, and we use another annotation for CloudEvent consumer. Let's take a look in detail at the code here. So I have now a class which has been annotated as a CloudEvent component, and I have a method here that's called public void on CloudEvent, and that is annotated as an event consumer, and it has an argument here with input data. So this means that events from a injected input are being delivered to your on CloudEvent method. And here we have the CloudEvent as the payload or the argument for the method, and the data field is optional there. So if the CloudEvent does contain some data, we will simply print the actual payload as a toString mechanism on the console here. So later on, when we run this in OpenShift, the event flow stream is leveraging cloud events over Kafka. But here, from an API perspective, you're just dealing with the standardized cloud event format instead of all of the specifics and details for Apache Kafka. All right, let's take another step in order to get the project going. We need to deploy it. Well, we need to create first a fedjar file, which is configured using the Maven Shade plugin in the POM file. Once we do have the fedjar file, we use the Docker Maven plugin for building our Linux container with the name that has been derived from the arguments in the archetype. So now I do have a Linux container that basically embeds my stream processor code, that tiny Java file. All right, we do have another file that's being generated. It's a resource definition or custom resource file for Kubernetes. So we have a kind for a processor. We have some metadata, my think. Again, this is derived from the Maven archetype. And I have an image name. That's my Docker Hub organization and the name of the actual Maven artifact. And as you saw before, there is a field for inputs and there's something like input data. So on the runtime, when my very simple Java code is being executed, we have a framework that's basically ensuring that input data, in this particular case, CloudEvents, are submitted to my function in that container. And under the scenes or behind the scenes, there's Apache Kafka, but it's completely transparent here. Okay, that is the file. And now I need to register this file with the CloudEvent flow component. I use kubectl for that, and I am now going to use the YAML file that's been generated as part of the archetype. All right, so what we see here is that a stream processor has been created. We have also the opportunity to actually check for all the processors that are in this system. So what we see here is we have a component that's called mySync, which is what we just developed here together. I did prepare another processor which is called mySource, and in this case it's again using the CloudEvent flow management APIs, and it's generating some random data, and the random data is then dropped into a CloudEvent and is delivered through our framework. The framework then is routing that CloudEvent object to a Kafka topic, and then eventually the mySync container is being invoked with that payload and is, as you saw in the code, is receiving it, and if data is present, it is printing it to the log file. All right, let's go back to the UI. Now, here is my manager UI, and I have an editor here where I can create a new flow. Oh, let's see. We now have a bunch of processors. We just created the log data, but I did prepare already a random data source here. I now say I want another processor, which is my log data. And now I'm connecting the dots here. So data that's generated by my Java file inside of the Linux container for the random source is generating CloudEvents and is declarative submitting that through an output data injected topic. And then it's routed by the framework to my logging container. And as you saw there in the code, the consumer annotation was saying I have input data. Okay, let me submit this flow. I save it as flow number 1. Going back to OpenShift, now we see that based on the definition or composition of the flow, I did in the other editor, I get a new application here that's called flow1, which represents the name of the flow. And I have 2 containers in there. My random source container that I prepared before using a different archetype. And then here is the log data that just prints out any data that is received through Kafka behind the scenes and then injected to my component here, printing the CloudEvent payload. Okay, let's go in there and let's take a little look at the log file. So what we see here is I get some random data. There's a data field that has a value, and there's indeed some random data. So, and here is some custom information on the cloud event. So we leverage cloud event specification 01 here. We have a different event type, and then this is the optional data, but in this case, the data is present. So this is basically the dynamic creation of a flow using our Processor SDK. To recap, with the use of the archetype, we were very quickly able to generate a complete setup for a project using the SDK, and also with the correct custom resource file for an easy deployment and registration. So once the Docker image has been built, I just need to register the processor using that custom resource file, and then I can leverage it in my Cloud Event Flow editor. That's pretty much for this demo. Thank you for watching.